Welcome to The Explainer. Today, we're diving into the source material on a breakthrough that could literally solve problems we once thought were impossible. Yeah, we're talking about a giant leap forward for a totally revolutionary new kind of computer. And no, this isn't science fiction anymore. This is the incredible promise of quantum computing, a field that just took a massive, massive leap forward, all thanks to a team of engineers at Princeton University. So, to really get why this is such a huge deal, we first need to talk about the fundamental building block of this technology. It's called a qubit, and trust me, it's unlike anything inside the computer or phone you're using right now. Your phone works with bits, simple on or off switches, a 0 or a 1. But a qubit is fundamentally different. It can exist in what's called a superposition, which just means it doesn't have to choose between being a 0 or a 1. It gets to be both at the same time. And that unlocks some incredible potential. Think of it like this, right? A regular computer bit is just a light switch. It's on or it's off. Simple. But a qubit? That's more like a dimmer switch. It can be fully on, fully off, or any shade in between. And that in-betweenness, that superposition, is where the real magic of quantum computing happens, because it lets the computer explore a mind-boggling number of possibilities all at once. With that kind of power, quantum computers could solve some of the world's biggest problems. We're talking about simulating complex molecules to invent life-saving drugs in a fraction of the time. We're designing revolutionary new materials from the ground up. Heck, they could even crack the encryption that protects most of our data today. The potential is just enormous. But for decades, one single massive problem has stood in the way. So what is this huge challenge? Well, it's a problem that has kept quantum computers pretty much confined to labs. A fleeting advantage that disappears almost as soon as you create it. As Princeton's Andrew Hauck puts it so simply, the real challenge is that you build one of these amazing qubits, and the information just vanishes. It doesn't last. There's a name for this problem: decoherence. The second a qubit interacts with its environment, and I mean even from a tiny vibration or a slight temperature change, poof, it loses all its special quantum properties. The information is corrupted, the calculation fails. It's incredibly fragile. This challenge was so unbelievably difficult that the quest to extend a qubit's life became known as a graveyard of ideas for physicists. I mean, it seemed almost hopeless. Until now. And this is where that team from Princeton completely changed the game. They didn't just make a small, incremental improvement here. They took an absolutely giant leap forward. That team built a new quantum chip with a qubit that can hold its quantum state, its coherence time, for over 1 millisecond. Now, I know what you're thinking. A millisecond? That sounds like nothing. But in the quantum world, believe me, that is an eternity. In fact, it's a staggering 3 times longer than the previous world record ever achieved in a laboratory. This is the biggest single jump in coherence time in more than a decade. And here's the kicker. It's nearly 15 times better than the coherence time in the big, large-scale quantum processors that industry leaders are building today. 15 times. So how on earth did they do it? Well, it was a pretty elegant 2-part innovation. First, they built the delicate circuits out of a robust metal called tantalum, which has way fewer defects. And second, they placed those circuits on a standard high-purity silicon base. Yep, the same material that powers pretty much our entire digital world. Okay, so why does this one breakthrough matter so much for the future of computing? What does a longer-lasting qubit actually, unlock? Well, this extended lifetime helps solve the 2 biggest roadblocks in the entire field: scaling up and correcting errors. It gives the computer enough time to actually do complex calculations, and this is crucial, to fix the errors that are going to happen. Without that critical window of time, building a big, useful quantum computer is basically impossible. And the impact here, it's not just a small bump, it's exponential. Researchers estimate that if you just swapped these new components into Google's best quantum processor, its performance could improve by a factor of 1,000. And as these systems get bigger, the benefits just skyrocket. A hypothetical 1,000 qubit machine built with this new design could perform a mind-blowing 1 billion times better than one using the parts we have today. That is the kind of leap that changes everything. So, what happens next? This breakthrough doesn't just improve the tech we have, it puts the entire field on the fast track to becoming a reality. Like Andrew Hauck said, this is the moment quantum computing moves from possible to practical. And a huge reason for that is that this design uses industry-standard silicon, which makes it so much easier for companies to adopt and eventually mass produce. This one breakthrough has dramatically sped up the timeline. What once felt like a really distant dream could now be a near-term reality. In fact, some researchers now believe we could see a powerful, scientifically useful quantum computer by the end of this decade. And all of this leaves us with one final, fascinating question. This isn't just a thought experiment anymore. With this fundamental barrier to scaling now kicked down, we really have to ask, what world-changing problem should we tackle first? It's a question we all might get to answer much, much sooner than any of us thought possible.